Assalamualaikum warahmatullahi wabarakatuh. I am fatihah binti Mohamad, no student 2020469532.
My name is syafawaty binti mohamad hazir and my student ID is 2020820434.
I am hidayah binti farizan 2019436876.
I am hamizatul nadhrah binti hanifah 2020620024.
I am nabila binti ramli 2020839386.
We are from CS 1433A would like to present about introduction and forward-backward method in chapter 3.
For today, I will introduce about the proof. What is proof? In mathematics, proof is a logical equivalence that shows that the statement is either true or false. Something which is show that something is true or correct. When the statement is given, we need to prove that A implies B, whether it's true or false. From that, the first thing that we will start is by find the hypothesis and the conclusion. For the example, the sum of the first n positive integers is n times n plus 1 divided by 2. The answer is the hypothesis is n is a positive integer and the conclusion is the sum of the first n positive integers is n times n plus 1 divided by 2. As a note, we need to make sure that the hypothesis is implied for the statement to make sense.
Now, we are going to learn which is the forward-backward methods. So, if look at the forward-backward methods, when proving A implies B, assume that A is true and use this information to reach the conclusion that B is true. We know that we have A implies B, which means that A into B. This is our conditional statement that we want to prove. In the forward-backward methods, you need to assume that A is true and use this information to reach the conclusion that B is also true. The statement in A is correct, so we don't have to prove it. So we just have to assume that information in A is true. Then you need to use whatever information in A to reach the conclusion that B is also true. We have to show and prove it. If we look closely here, we have a forward-backward process most of the time, and most of the question we meet, most of it we will use the forward process. But then whatever it is, we are going to mention it here. So the forward process happen when you use the information contained in A to prove that conclusion B is true. Whereas if in the backward process, if we see at slide, it happen when you attempt the reach conclusion that B is true, but statement B without using A because there are no information in statement A. That is the difference between forward process and backward process. We will only use the backward process when the information in A does not give any definition or information that we can use to show that B is true. So now I will explain the forward process. Before proving any proposition, we need to identify the statement A and B, which means that A, the statement assumed to be true, hypothesis, while B, the statement to be proven, conclusions. Generally, everything between the word if and then it the hypothesis, while everything that come after the words then is the conclusion. After that, from statement A, then derive conclusions A1. Let the last statement of the countdown process cut you. A1 must prove that statement A is logical. If A1 is the last statement from the forward process, then the proof is complete. If not, use statement A and A1 to draw conclusion A2. Continue to obtain A3, A4 until the last statement from the forward process is obtained.
Okay, next we move to backward process. In backward process, the main point is we need to assume B is true, and for sure we must to prove it. And basically, backward process will be used when statement A didn't give any information to prove the statement is true. So, the first key question in backward process is how can I conclude that the statement B is true? From here, we need to ask ourselves, how can we conclude statement B is true? Next step is we need to find the answer of key question. So, the first thing to find the answer of key question is to give an extra answer that contains no symbol from the specific problem. From here, it shows that we need to find another answer from the statement we get. And the second thing to find the answer of key question is to apply this extra answer to the specific problem using appropriate notation. So here is a simple example that I choose. If ABC is a triangle with AB equal to BC and the angle B is 19 degree, then the area of triangle is AC over 2 square. From the statement, it shows that the green line is statement A, which is starting from ABC until 19 degree, and the yellow line is statement B, that is area of triangle is AC over 2 square. So, we need to rewrite statement B, which is area of triangle is AC over 2 square. From the statement B, we need to create key question. And for this case, the key question that we find is how can I show that the area of triangle is AC over 2 square. Okay, back to our second step, which is we need to find answer for key question, that is give an extra answer that contain no symbol. So, the answer for key question that I can show is formula area of triangle. And finally, if we think logically, how can we conclude this statement is true if only given the area of triangle? It is impossible because actually we need more information to show that this statement is true. So, clearly show that for this case, we cannot use backward process, but we need to use forward process to show this statement is true. Next, I will explain how to write condensed proof. Actually, condensed proof is we summarize what we solve. For condensed proof doesn't have any fixed answer, but the most important thing to write condensed proof is we must not miss any important step or important point. And here is one of example condensed proof.
Okay, example 1. If the right triangle XYZ is an isosceles triangle, then the perimeter of the triangle XYZ is open brackets square root of 2 plus 2 close brackets times one of the congruent side. So, to prove this proposition, it can use analysis of proof. Firstly, we must to know A and B. A is the right triangle, XYZ is an isosceles triangle. Then, B is the perimeter of the triangle XYZ is square root of 2 plus 2 times one of the congruent side. B1, perimeter XYZ equal to square root of 2 plus 2 times A. A is the congruent side. A1, we must to find isosceles triangle in term MAT, which is XZ equal to YZ equal to A. Perimeter equal to Z plus A plus A. Next, A2, we must to find the side Z. Z is equal to square root of A power of 2 plus A power of 2 equal to A square root of 2. A3, to find perimeter, it must to calculate all sides. So, perimeter is equal to A plus A square root of 2 equal to A multiply square root of 2 plus 2. So, this is the proof for B1.
So for condensed proof in example 1, you just summarize from the analysis of proof and the answer is From the hypothesis and definition of isosceles triangle, let congruent side xy equal to yz equal to a. Then using the definition, we are trying to show that parameter xyz equal to square root of 2 plus 2 times a. By using Pythagorean theorem, we solve it and we get xz equal to a square root of 2. After that, substitute xz equal to a square root of 2 xy plus yz equal to a into parameter and we get 2a plus a square root of 2. Then we factorize a and we get a times square root of 2 plus 2. Hence, the parameter xyz is equal to square root of 2 plus 2 times one of the congruent side is proven. Next is example 2. So the question is, if a and b are consecutive integer and a is even, then a squared minus b squared plus 7 is divisible by 2. So in this question, I use forward method by using analysis of proof. So the solution is, first we need to find our hypothesis A, which is A and B are consecutive integer and A is even. And conclusion will be B, which is A squared minus B squared plus 7 is divisible by 2. Next, after we have A and B, then we write our B1. B1 is so important because B1 is what we want to prove. So our B1 is A squared minus B squared plus 7 equal to 2k. So after that, we can write our A1, which is we take the information from A. The question tells us that A and B are consecutive integer. So we know that the consecutive integer is the difference between two integers is 1. So that means one must be even integer and another one is odd. So the question also gives us A is even. So if A is even, then B must be odd. Next, we just write A equal to 2m because the definition of even integer, and B is 2m plus 1 because it is odd integer for some integer m. After we get A1, we can move to A2. In A2, we just substitute A equal to 2m and B equal to 2m plus 1 into A squared minus B squared plus 7, and we solve it, we get 6 minus 4m. After that, we factorize it until it was equal to 2k like we want in B1. So we just factorize it and we get 2 times 3 minus 2m. Then for A3, we just conclude that A squared minus B squared plus 7 equal to 2k for some integer k equal to 3 minus 2m is proven. So it's same like in B1. So this is our solution for example 2. For condensed proof, you just summarize from analysis of proof into a statement and we get the answer like in this video.
Next, example 3. If the m is an odd integer and 4 divides m, then 2 divides mn. By using analysis of proof, I will explain how to prove this proposition. Okay, A, m is an odd integer and 4 divides n. Next, B, 2 divides mn. B1, mn equal to 2k for some integer k, because mn divided by 2 equal to 2k, so mn equal to 2k. A1, m equal to 2p plus 1 for some integer p, because it's based on definition of odd number. A2, n equal to 4r for some integer r, because n divided by 4 equal to r, and we get n equal to 4r. A3, substitute m and n into mn and we get 2p plus 1 multiply 4r equal to 8pr plus 4r and factorize 2, then it got 2 multiply 4pr plus 2r. A4, mn equal to 2k for some integer k equal to 4pr plus 2r. So this is proof for B1. So here is the content proof for the example 3.
So now I will explain the last example. So the question is, if n is an integer and n squared is even, then n is even. Proof by using the forward-backward method. So for this question, I will explain and prove by using backward method. So the solution is, first we write our hypothesis and conclusion, A and B, which is A, n is an integer and n squared is even, and B, n is even. So next, how we want to prove it? Firstly, we make statement for B1, which is B1, we start with our key question because it was backward method. So the question is, how can I show that n is even? So we need to remember back what is the definition of even integer. So the definition for even integer is n equal to 2p for some integer p. After we get the n equal to 2p, now we can construct our next statement, which is A1. For A1, we use the information from the hypothesis A to substitute n equal to 2p into n squared, and we get 4p squared. But 4p squared not showing that it was even integer. So what we need to do, we need to factorize it, and we get 2 times 2p squared. Then we get our definition of even integer n equal to 2k for some integer k 2p squared. Thus, this proves the conclusion n is even. So this is our solution if we use backward method.
For the conclusion, we can conclude that from the forward-backward method, we can find the proof by two directions, that is from the conclusion backward and from conclusion knowledge, definition and given forward. Based on this method, the forward process is the most helpful for the students to use. This process will use until the last statement derived from the backward process is obtained. Lastly, the benefit of this process is you can combine and use the new statement to produce more true statements.
That's all from us. Thank you for watching.